Let's go to page 287 and let's start with number 434. So it says a T, it's a sixth term, so you're looking for T6, and it gives you the 31st term, so T31 is 18, and T73 is 46. Okay, so let's go and use these two information to find D. So T of 73 equal to T31 plus D times, and because you're using 73 and 31, so you'll be 73 minus 31. And then you substitute the value in there, so T73 is 46, T31 is 18, and then you can work this out, so this will be equal to 42. Okay, then minus 18 on both sides. So you got 28 equal to D times 42. Then you divide by 42. So D equal to, and this you can reduce by 14, so it'll be 2 over 3. Okay, so I circle the important information. Once you find D, then you can find T6. Okay, so T6 will equal to, now you can use either one. Okay, so you can use either one. I'm going to use this one over here where you equal to T31 plus D times, and since you use the 6 and 31, so it will be 6 minus 31. So T6 will equal to 18 plus 2/3 times negative 25. So T6 will equal to 18 minus 50 over 3. So T6 will equal to 4 over 3. Okay, let's go to the next one. Okay, it says the second term of geometric. Okay, so this again, write down all your information. So geometric, and T2 is 4, and the T6 is 16. Find the T4. Okay. Well, instead of looking for all the form, notice that this is the middle term of the two. So this is a geometric mean. So the easier way to do it, just go and use the geometric mean technique. So T4 will equal to the square root of 4 times 16. So T4 will equal to 8. And that's it. Okay, let's go to the next one. Okay, so you're going to evaluate this sigma notation. So you have the sigma of n equal to 0 to infinity of 3 to the n plus 5 to the n over 8 to the n. Okay, so to evaluate this, it's easy if you separate this into two different terms. So that's going to do that. It will be 3 to the n over 8 to the n plus sigma of n to the 0 to infinity of 5 to the n, 8 to the n. Okay, and this one you can make it into one fraction. So it would be 3 over 8 to n, and do the same thing over here. Be 5 8 to the n. Okay. And what you want to do, you want to write out a couple terms. So this is equal to, so when n equal to 0, anything to the 0 power is 1, and when n equal to 1, it would be 3 over 8. And when n equal to 2, it means you square. So you got 9 over 64 and dot 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 dot. Okay. This one over here, this one again do the same thing. So when n equal to 0, you get 1. So I'm going to do this. Okay. And when n equal to 1, you're going to get 5 over 8. When n equal to 2, you get 25 over 64 plus dot dot dot. And it goes to infinity. So this is the infinite series. Okay. And the formula for infinite series is the sum is equal to T1 over 1 minus R. Okay. So this one would be equal to T1 would be 1 over 1 minus, now the R is 3 over 8. Okay, the common ratio. You multiply by 3 over 8, multiply by 3 over 8. Okay. Plus, this one is the same thing with T1 is 1 over 1 minus R, in this case is 5 over 8. Okay. And then from here, this will equal to 1 over, okay, so complex fraction, again, there are several ways you can solve this. You can multiply it by 8 if you want to, so that's going to do that then. Okay. Or you can just simplify this and flip it over, either way. So you got 8, so you're going to end up with 8 over 8 minus 3, so you go to 8 over 5. Okay, this one is the same thing, multiply 8 by 8. So it would be 8 over 8 minus 5. So it would be 8 over 3. So when you add, you get common denominator of 15, so it would be 24 plus 40. Okay. So this will give you 64 over 15. Okay, let's go to the next one. Okay, so you have a 1 plus x squared plus x cubed plus x to the 4 plus dot 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 equal to 4. So you're solving for x. Okay, so again, the formula, the S for infinite series are infinite sum, sum equal to T1 over 1 minus R. Okay, so if you can, so the S is 4, so you're going to get 4 equal to T1 is 1. And 1 minus, the ratio would be the x. Right? Notice you multiply x to get the next one, so common ratio would be x. Okay, so from here we can go ahead and solve. So cross multiply 4 minus 4x equal to 1. And move this over, so 4 equal to okay, so move this over, so 4 equal to 1 plus 4x. Okay. And then minus 1 on each side. So you got 3 equal to 4x. Divide by 4, divide by 4. So x equal to 3 over 4. Okay, let's go to the next one. Okay, it says find the sum of the first 40 terms of the series. So you have negative 59 plus negative 56 plus negative 53 plus dot dot dot. Okay, so this would be T1, T2, and all the way to the 40 terms, so T40. So you're looking for S40. Okay, so again, since you're looking for sum, so write down the S40 equal to 40 over 2. Okay, and again, this is arithmetic, right? Again, if you use remember the formula. So whenever you have arithmetic and it's sum, so right away you start with this formula. Okay. So you're going to get T1 negative 59 plus T of 40, which you don't know. So again, the formula is S of n equal to n over 2 times T1 plus T of n. Okay. So that's this, this is this. So now we have this missing. So we leave a blank for now, and we're going to use the other formula to find out whatever. Okay. So again, the formula is T of n equal to T1 plus D times n minus 1. Again, n and 1 are just generic. You can use any number. So we're looking for T40. So it'd be T40 equal to T1 is negative 59 plus D. Okay, so from here to here, the D common difference is 3. Okay, so here, so it'd be 3 times n minus 1. So again, from here to here, that's common difference, right? You have to add 3 to get to the next term. So T40 equal to negative 59 plus 3n, or n is 40. Okay. So it'd be 3 times 39. So T40 will equal to negative 59 plus 117. So T40 equal to 58. So again, when you go up to the side to find out what you're missing, and you substitute back in here. Okay, so you start with your major step, go off to the side, doing the minor steps, and you substitute back. That way you don't lose the train of thought. That way you don't get, you lose track of what you're doing. Okay, so put this over here. All right, I can substitute this into here. So sum of 40 terms. So this will equal to negative 1, and this is 20, so it will be negative 20. Okay, let's go to the next one. Okay, number 439. If the 5 geometric means are inserted between 8 and 5832. Okay, so T1 is 8, and so 5 terms are inserted, a total of 7 terms. So T2, T3, T4, T5, T6, T7, and this would be 5832. Okay, and you're looking for the 5th term. Okay, so you're looking for this one over here. So again, you got 2 numbers, and you're going to insert 5 geometric mean between here. Okay, again, and then write down all your information. So this is geometric. Okay, so from here we can find the common ratio. So again, for geometric, once you notice the common ratio, you can figure out any terms. So let's go and use so it's geometric, and you're going to use this formula. Again, one formula for sum, the other formula for everything else. Okay, so use this formula over here. So you got T of n equal to T1 times R to the n minus 1. And I'm going to use a 7 and 1. Okay, so I'm going to use the T7 and T1. So T7 will equal to T1 times R to the 7 minus 1. So 5832 equal to 8 times R to the 6. So divide by 8, divide by 8. So 729 equal to R to the 6. And so R equal to 3. Okay. Now, see, when you take the 6th root, you can have a plus or minus 3. But since we deal with geometric means, we usually just take the positive. Okay, so once you find the R equal to 3, now you can use a formula again. So you can use this over and over and over until you get what you want. So you're looking for T5. Okay, so T5 will equal to, I'm going to use, again, you can use any of the term that you know. You can use T1 or T7. So I'm going to use T1. In this case, it would be 5 minus 1. Right? Okay, that's going to substitute stuff in here. So T5 equal to, T1 is 8 times R equal to 3 to the 4 power. So T5 will equal to, again, you work it out, you're going to get 648. And that's it. Okay, let's go to the next one. Okay, it says find the sum to infinity of, so you got 1 over 7 plus 2 over 7 squared plus 1 over 7 to the 3 plus 2 over 7 to the 4 plus dot dot dot. So this is the infinite series. Okay, so the easier way to do is go and separate this into 2 different series. Notice one of them have 1, 1, right? The other one have 2. So this will equal to 1 over 7 plus 1 over 7, 3 plus dot 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 dot. Okay, so that's one series. Plus 2 over 7 squared plus 2 over 7, 4 plus dot dot dot. Okay, so separate this in this way. So your infinite series, the formula is sum equal to T1 over 1 minus R. Okay, so remember note your formula. So this will equal to, so the sum will be equal to T1 is 1 over 7, right? That's T1 the first term. 1 minus, okay, R, the ratio is going to be 1 over 7 squared. Notice you have to times by 7 squared to get the next one. So it'll be 1 over 49. Okay, again, 7 squared is 49, right? 7 squared is 49. So that's your R. Okay, again, you have to times by 1 over 7 squared. Okay, this one you do the same thing. Okay, so T1 is 2 over 49 over 1 minus, again, this one is 1 minus R, is the same thing. R is 1 over 49, right? You have to, so your R is equal to 1 over 7 squared for both of them. Okay, and so R equal to 1 over 49. Okay, so now you have to work these things out, right? Now again, to work this out, you can multiply by common denominator. So multiply by 49 for each term. So you're going to get 7 over 49 minus 1. This one again multiply by 49. So this cancels out, so you're going to get 2 over 49 minus 1. And since this you have a common denominator, you can make into 48 already, and this you're going to get 9. And then from here you can reduce by 3. And so that's it. Okay. Now this is not the only way you can solve the problem. There are other ways you can solve this one, but this is a little bit more straightforward and I think it's easier to do.